In this video, we'll go to plot cumulative frequency distribution with Python and without Python. Then, in our terminal, we need to import numpy as numpy. Remember that numpy is the standard convention of numpy in all forums in network. We need to import matplotlib.pyplot as plt. We need to import scipy.stats as stats. Finally, import seaborn as CMS. Okay, we need points, we need data. Our data is p.random.rand with n in the end of the word rand, because our data is in normal distribution, and with 500 points is enough, I think. Okay, we have data. The first thing is plot the data with plt, with plot x, and the symbol is dot. This is the object, matplotlib, line to d, etc., etc. We'll show our data, and surprise, this is the plot. We have this scatter plot, and you remember that our data is in normal distribution. This is this line, normal distribution, 500 points. Then we have a zone with many points, maybe it's close to the zero, and here there are the concentration of data, and in this part too, but it's more dispersion in the frontiers of this plot. The concentration of data is in this zone. And okay, a plot that can help us to understand better the problem is an histogram. The histogram of this data we can plot with cms dot this plot, distribution plot, with our data. Other parameter is kernel distribution estimate, in this case with false option, and norm east true. We want our data, our plot, in normalized. This is our plot. it is beautiful. And in this plot, we can see that the majority of data is here, is in the zone. And in this zone, there are data, yes, but there are more in this zone. This is the utility of our histogram. Okay, but we can plot a line that fit to our histogram. This line is the kernel distribution estimates, and seaborn can help us with the same plot. In this parameter, we can write 2. This is the kernel distribution estimates. Okay, it is beautiful too. This is the plot. Okay, this plot is very, very close to a normal distribution. And remember that in a normal distribution, we have a Gaussian shape. It's more or less this. And this area is the probability, total probability. And the total probability for this is 1, the total probability. This is the same case. This area represents all the probability. Then, what is a cumulative distribution function? Is a plot that represents the same problem. For example, in our data, we have this utility. The lines plot for cumulative distribution. What we need before the cumulative distribution data. Cumulative was normal. CDF is a variable, is our variable of cumulative distribution function. And it is stat dot norm dot cumulative distribution function of our data. And the plot it is cns dot line plot with x and y. Y is a normal CDF, and it is our object, and this is the plot of this. But it's more clear if we plot both graphs in the same plot, in the same panel. And then this plot and this, we can merge. And it is what represents this plot? Represents that, for example, for this point, for this area, that represents this variable, this area, represents a probability. Do you remember? Area is probability for this variable is in this form. Then is the same for this. This area is represent for this point in this plot that represents this probability for this. Is other manner to get the probability for in terms of area in terms of the plot of cumulative distribution function. For example, for this point dot 2, we have this area but it is equivalent to this point in the plot. Okay, I hope that this video will be utility for you, and I'll see you in the next video.